And I think last time when we spoke, we were talking about the potential benefits to the railway power infrastructure of both of those energy types in terms of relieving pressure on the existing overloaded power systems in terms of electrification.
Well, yeah, certainly. Onboard battery systems can be quite useful in that sense, particularly where you have a DC electrified railway, such as in the southeast of England or up around the Liverpool region, where you can actually use the batteries to capture regenerative energy that would otherwise be have to be wasted as heat or lost in the system, because a DC railway can't accept that energy back into the network. So from that point of view, you can start to reduce the demands you place on the network through the use of the battery. And you can also travel beyond the extent of the network, of course, as an autonomous unit. So you can operate where the electrification doesn't quite reach, up to a certain range. So from that point of view, you may be able to set in services that travel further overall, but don't increase the energy loading on the network significantly. And in that way, you avoid excess draw on the grid supplies to the rail network. And in the case of hydrogen, of course, you have the option to travel further autonomously, and all the hydrogen units that we use also, or that we propose, are hybrid drives. So they use batteries on board for exactly the same purpose. They would capture regenerative energy as the train slows down, and then they will redeploy that when the train is accelerating, so that you optimize the energy efficiency of the system. So in a way, both of them complement the electrification network, but they're neither of them is as efficient as electrifying the full route, of course. But that's that's the trade-off you make as you assess what the best technology, the best cost, the best technical fit, the best aesthetic for the route is.
Yeah, and of course hydrogen has the benefit of that it's got its energy source on board in the tanks of hydrogen that are there. Where the battery is concerned, I know I've had it expressed to me a concern over the power capacity or availability of spare capacity to charge battery trains along the route, and how that would be managed, because obviously it would be a bit pointless having a battery train delivered and then having to upgrade the power capacity of the of the overheads or the DC traction power system to cope with that. So is there any sort of intelligence out there about the range of power capacity for battery charging, or whether it's better to charge the battery when the train's stationary, or is there any?
I think it's a route specific and an operation specific decision that has to be made. I think you'll find that there are in certain areas there will be sufficient energy available to recharge the battery from either overhead or other electrification sources in certain routes, in certain operations, perhaps where the battery operated section of the route is to a terminal station. You could have a charging point at the terminal station and charge the train there and not be dependent on the electrified network at all for your charging, or you may have a mix. And again, you need to put that together in a kind of detailed simulations as you determine the exact way in which you need to operate the train for any given operation.